Well, here we are with lesson 17, confidence intervals, this time about the mean or the average. So in this example, I have a sample size of 40. So I'll write that down, n equals 40. And the sample mean, x bar, is 80. And the standard deviation is 12. So S equals 12. And like most times, I'm going to do the first one using the formula, and then I'll show you how to use the calculator to do it. So create the 95% confidence interval for the mean. So in other words, this is the average 80, but because that's only based on 40 people, there's going to be some error. And the formula for the error goes like this. It's T sub alpha over 2, the critical value, and then the standard deviation divided by the square root of n. So this t value, I don't think we've used before, and you can use the calculator, I'll show you. You can also use this, which is called table A3, or the critical values for the t distribution. So before I show you how to use this, first let me just draw a graph. So the t distribution does have a normal distribution, and I'm then saying to use 95% level of confidence. So a confidence interval always has a left side and a right side, and we're saying that in the middle is 95%. And if you subtract 1 minus the 0.95, that's alpha, so that equals 0.05. And then because the two tails are symmetric, divide that by 2. So it's going to be 0.025. So this side has 0.025 and this side has 0.025. And now we're about ready to use the table. One little detail when you use table A3 with the t distribution is you need to know degrees of freedom, and that's just going to be n minus 1. So degrees of freedom, which I like to just abbreviate df for degrees of freedom, is just n minus 1. So in this case, that's going to be 40 minus 1. Degrees of freedom equals 39. Okay. So notice that when you look in one tail, if you only look at one of the tails, that's 0.025. And also degrees of freedom is 39. So if you're using the table for the t distribution, the degrees of freedom is over here. So then we just go down until we find 39. And if they don't have 39, you just use whatever's closest. So there is the 39. So then I would highlight that row. So that's going to be the correct row. And then along the top, this part is saying if you look at one tail, it has 0.05. So, excuse me, 0.025. So that's what we're going to use, this middle column right here. If you looked at one tail and it had 0.05, use this column. If you look at one tail and it has a 0.10, you use this column. So for one tail it has 0.025, so use the middle column, and then go down to degrees of freedom is 39. So here's where it says 39, and then if you go to the middle column, that says 2.023. 2.023. 2.023, and then that's called t sub alpha over 2. And actually the one on the left would be negative and the one on the right would be positive. All right, if you're not using that table, then use the calculator and you go to second distribution, and then it's the number 4, the inverse t. And the area would be 0.025, so we're talking about one tail. and degrees of freedom was 39. And then it says, so it gave me the same number. So 2.023, 2.023. Now it actually gave me the one on the left first, and that's even the one that I found first. Okay, the next part with using the formula is do that. So this is going to be the 2.023, this will be the 12, and this will be the square root of 40. So in other words, the error equals 2.023, and then times the standard deviation, which is 12, and the square root of 40 people. So 2.023, and then times 12, and divide that by the square root of n, so the square root of 40. And that equals 3838. So the error is 3.838. And then to make the interval, so the mean is going to be between, so now take whatever the x bar is, 80, and on the left, subtract the error, 3.838. And then on the right, do the same thing, except add the error, 3.838. So on the left, it's going to be 80 minus 3.838. And then on the right, it's going to be 80 plus 3.838. So the number on the left will be 76.162. And the number on the right, 83.838. All right, that's the confidence interval. So based off those 40 people, we could say that the average is going to end up to be somewhere between 76.162 and the 83.838. And then to use the calculator. So you go to Stat, move over to Tests, and then move down to number 8, the t interval. And data would be if you had a list of data. Stats is what we have, the sample statistics right here. So that's fine. And then this should be the x bar is 80, the standard deviation is 12, and the sample size is 40. And then use 95% confidence level, so that's already set up. And then go to calculate. And on the right, it says the exact same thing, 83.838. And on the left, it says the exact same thing. So now I can even circle my answer. All right, like I said, one time I'm going to use the formula. And then for the other two examples, I'm going to use the calculator. So for the next example, so this is information from the US Census. A sample of 491 college graduates. They made an average of 124,500, and then there's the standard deviation. So even when I use the calculator, I'm still going to write down the information to show how I got the answer. So n equals 491, and they made an average of $124,500, and the standard deviation 23,450. And then I'm going to use the t interval rather than the formula. So that's basically all the information I need. It is a 95% confidence level. So then basically redo what we just did, go to the stat, and then the tests, And then number 8, the t-interval. And this time the mean is $124,500. Standard deviation 23,450 based on 491 people. Confidence level is still 95%. And by the way, if the confidence level ever is missing, then you always use 95% as a default. All right, then calculate. So this is for college graduates in the United States. Then they're making on average, on the left, it's $122,421. And on the right, $126,579. All right, next up, right next to where I found that data, they also had for high school graduates. So for high school graduates, they had 322. This was actually, to tell you the truth, this was actually like 3,222,000, and this was like 4,900,000. Anyway, we'll just make it 322. I didn't change any of the other information, I just changed that. And then they made an average of 54,350. And the standard deviation, S, equals 16,540. And then again, use the t-interval. And let's see how much money they make. So go to Stat, Tests, and then the t-interval. So this is now, the x-bar is 54,350. The standard deviation 16,540 based on 322. And it also says use 95% level of confidence, so leave that the same. And so then they would be making on average somewhere between $52,537 and up to $56,163. So then you could see, if you compare the two intervals, would you rather be making 126,000 or 56,000? Would you rather be making 122,000 or 52,000? So graduating from college seems to pay off.